name is Brian Hubble, and today I'm going to be talking about the geotechnical performance functions, and they relate to flood planning studies. I'm a geotechnical engineer, and I work in the South Pacific Dam Safety Production Center. You can reach me if you have any questions about this talk, and we can find your answers. The presentation for today is really going to be kind of 4 parts. The first is, what is geotechnical engineering? And so I realize that the audience for this presentation is probably a mix of various engineering disciplines, civil, structural, geotechnical, but probably has a large number of planners, environmental folks, biologists, and also economists. So just a quick overview of what geotechnical engineering is so that people can understand what a little bit the geotechnical engineers and geologists are talking about when they talk about the work that they need to do. So just, from Wikipedia, this is modified just a little bit, but geotechnical engineering is a branch of civil engineering that deals with the behavior of earth materials, basically soil and rocks. And so we work with geologists and the other engineers to solve problems and predict the behavior of soil and rock materials. So for our flood control structures, which are often levees or flood walls, we found them on soil or rock. That's the foundation. We have to understand how that's going to behave. And we also build them out of soil and rock. So we work both trying to understand what's there by nature and what we're going to build as engineers. Typically, geotechnical and geologic studies start with desktop studies and end with, they work their way from kind of a regional big picture scale to site-specific investigations and analysis. So here, you can see we start by looking at the regional geology maps. We make site-specific geology maps, and then we perform investigations to understand how the site-specific properties of different materials will impact the performance and the design of a project. So this is Prado Dam down in LA. They're working on the spillway down there, and so this kind of shows the regional geology map in the top part, and then on the bottom we have site-specific investigations where they did geologic trenching looking for faults, and geologic formations and borings where we evaluated different, we performed borings to identify the different types of soil materials and test them for engineering analysis. Once the field investigations are complete, borings and trenching and other field investigations, the samples are sent for the lab for evaluation, and there's a whole different range of kinds of lab tests that can be done. The strength of materials can be evaluated, the permeability of the materials can be evaluated, the grain size is evaluated, the plasticity of the different materials is evaluated, the compressibility is evaluated, stress history. So all these things are evaluated in the lab on different samples, and it's important to note that not every investigation answers every question about every material. And so, for example, when we talk about using old data or existing data to evaluate a current planning project, it's important to note that whatever that old project was that was performed was not the same purpose. The investigation, geotechnical investigations, is what is being considered now. And so there's a lot of uncertainty and interpretation that has to be made, and judgments sometimes if we don't have enough money to do investigations and lab testing in our current project. But it's important for everyone to realize that just because we have old borings and lab data, it doesn't mean it's the information that's needed for the current work. So for example, if we were building a building in a location, what would probably be very important is the consolidation and stress history and strength of the materials. But if we were tearing that down and building a levee in the same location, yes, we might have some boring information, but we don't know is it permeable, or certain things that might be important to the design of our levee. So here on the left just shows an example of a strength test that might be performed in a laboratory test. And then on the right, what we're showing are kind of how all our lab tests might be compiled and reported in a geotechnical report that might get attached to a planning study. I think it's important to note that there's thousands and thousands and thousands of probably pages of work that get consolidated into these tables, and so while the table in itself may look rather simple, there's a lot of work that goes behind in how that information is determined. Once we have that information, the geotechnical engineers perform a lot of analysis or based on what the project needs. So, typical analysis that geotechnical engineers are responsible for include slope stability, seepage analysis, settlement analysis, bearing capacity, lateral earth pressures for retaining walls, filters, design compatibility, so for draining and safely filtering embankment materials, dewatering designs. So during construction, it's important to keep the construction area dry, and the dewatering is important. If you're building structures, pile capacity, both axial and lateral, is important. In some situations, in high seismic environments and kind of a permanent pool condition, the geotechnical engineers are asked to produce earthquake ground motions and probably assess liquefaction potential based on the conditions of the site. So there's a lot of different things that the geotechnical engineer does with all that information. Here you can see this is a model for a levee project I worked on, and this is a model of the ground conditions for a seepage analysis. So there's I think 11 different soil layers used in this model for one calculation. So anyway, it just kind of helped illustrate what geotechnical engineers do for planning studies. Once we have analysis for planning studies, the geotechnical engineer really is there to assist with evaluating the performance of existing flood control systems and recommend designs for improvements to the systems. And so on the left is an example of a geotechnical system response curve for a project, and how it relates the probability of this levee failing to the water elevation loading on the levee on the bottom. And so for this example, 5 different failure modes had potential to impact the levee, and then the overall failure mode in the orange is a combination of the other failure modes. And then once the project is determined that there's a need for a new project, in engineering and design, the geotechnical engineers provide recommendations for design. And so here would be kind of a simple table of what might go into planning a new levee. So it might have a certain crest elevation, crest width, and slope angles, and erosion protection matting on it, and various things. So this is just to kind of illustrate what the geotechnical engineer does. So please give me a call if you have questions about what a geotechnical engineer might be proposing for your project, if you'd like me to weigh in or suggest how it might be changed or improved. So that's all I got for Module 1.